Okay, we are ready to start looking at triangles and comparing them and deciding whether the triangles are actually similar to each other or whether they're not. And if you recall back in chapter 4, we talked about whether or not triangles were congruent. And in order to determine whether triangles were congruent or not, we used different shortcuts. We used the side shortcut, SSS. We used the side angle side shortcut. We used angle side angle. We used angle side, and we used the HL, the hypotenuse leg. Do you remember those? Those were the shortcuts used to prove congruence. Okay? Now, these aren't the shortcuts that we use to prove similarity. We can't use all of them. Okay? There are shortcuts, though, however, for showing that triangles are similar. Okay, and it says we don't need to show that all angles are congruent and all sides are proportional, like we did in the previous section. We don't have to show that. We have shortcuts. Here are the 3 shortcuts, and we only have 3. Okay, right here. We have side, side, side. If we can show that all 3 sides of the triangles are proportional to each other, then we know that we'll have similarity. Not congruence, similarity. If we can show that 2 of the sides are proportional and 1 angle is congruent, side, angle, side, we will have similarity. Or if we can show that 2 angles are congruent, we will have similarity. So this is what it's going to look like. You're going to be given a set of triangles and you're going to decide which shortcut was used. So here's an example for each one of them. It says, are these triangles similar? Keep in mind that we have 3 different possibilities. We can use side, side, side. We can use side, angle, side, or we can use angle, angle. So you want to look at what information you're given. Well, these values that I'm given, okay, 6 and 8, I'm given 10.5 and 14, given 12 and 16. Are those angle measures or are those side lengths? Okay, hopefully you're saying, hey, those are side lengths for 2 reasons. 1, they're located outside of the figure, and 2, they're kind of in the middle of the side. So we want to determine, are those sides all proportional to each other? So we're going to take 6 and we're going to set it in a ratio with its corresponding side. This side on the figure corresponds with this side, so we make a ratio out of it. And we see if that ratio is the same for another set of sides. Since 6 is in the top of the ratio here, I have to put 10.5 in the top of the ratio. And how do I test to see if that's proportional? Well, I test the cross products. I'm going to take this product. Okay, so 6 times 14. Okay, that's equal to 84. And I'm going to set that equal to this product. 8 times 10.5. That's also 84. So you can see, because the products are the same, they are proportional to each other. And I've got to test another one. I'm going to say 6 over 8 is, go back and use that 6 over 8 again. I could have used 10.5 and 14, but I'll choose smaller numbers. So 6 over 8, is that proportional to this? 12 over 16. Again, 6 and 12 are coming out of the same triangle. They're both in the same place in the ratio. Okay, and I'm going to test the cross products. So I'm looking at this product. 6 times 16 is 96. Does that equal 8 times 12? Okay, that also equals 96. So those are proportional. Since you have all of your sides proportional to each other, are they similar because of side, side, side? Are they similar because of side, angle, side? Or are they similar because of angle, angle? Okay, well, all we've been given is the sides to test. So we would say that those are similar because of side, side, side. All of the sides are in the same proportion. So those 2 figures are similar. My similarity statement would be triangle A, B, C is similar. Remember that symbol for similar. And how do we name the second triangle? Well, which angle corresponds to A? I began with A, so which angle over here? I would begin with Y. I went up to B, so then I'd go to Z, and then I'd go to X. And my reason would be side, side, side. Okay? Okay, let's look at the next figure. Are these triangles similar? And it says name the shortcut and write the similarity statement. Okay, well, I can look at the angle. These two angles correspond to each other, and in order for triangles to be similar, angles have to be congruent. Congruent means equals. So those two angles have to be the same, and they are. You can just tell that by looking at it. There's no math to do. Okay, I do have to test the sides. This side 10 and this side 12.5. That proportion, that ratio, has to be in the same proportion as the other set of sides. I'd say 16 over 20. Again, these two sides, 10 and 16, are coming out of the same triangle. They need to be in the same place in the proportion. Okay, I'm going to look at the cross products. So 10 times 20 is 200. That's equal to, is that equal to 12.5 times 16? That one I'm going to do. 12.5 times 16. Now that equals 200 also. So that's in the same proportion because those are equal to each other. So we have sides that are proportional and we have the angle in between. So I would say that yes, these two triangles are similar to each other. Let's say I'm going to name this something different. I'm going to say that this is triangle BCA, and that is similar to triangle. Since I started with B this time, I'd have to start with Z in my name. And I went down here to C, so X corresponds to that, and then over to Y. Now, I forgot in the previous example, we need to have that little triangle symbol with our answers. Okay, again, these aren't angles, these are triangles that we're comparing. So I've got to have the triangle symbol. Okay, and then my last example here says, are these triangles similar to each other? And what we have to do is we have to find two angles that are congruent. If two angles out of a triangle are congruent, the third one has to be, because the angles both add up to 180. Okay, so I'm going to test angles. I've got an angle here, and I'm missing the angle there, so I can't compare those. I have an angle up here, and I have an angle up here. Now those are congruent. And then I've got an angle here, but I don't have it over here. So we've got to figure out, we've got to find some missing angles. And it doesn't matter which one you do. I'll take this first triangle. I know two of them. So if I take 88 plus 54, okay, I get 142. Let me just check that out here. 88 plus 54 equals 142. And I want to subtract that from 180. So 180 minus 142. Okay, if I take 180 and I subtract that 142, I'm left with 38 degrees over here. Okay, does that match up with the angle that corresponds to it? It sure does. So if I would have tried to find the missing angle over here, this would have been 54 degrees. All three angles are the same, so we would say yes, those two triangles are similar. I would say triangle, I'm going to name it this time CBA. And remember, it doesn't matter how you name the first triangle, but it is similar to triangle. Because I started with letter C in this triangle, I've got to start with the angle that corresponds to C, which is X. Then I went up to B, so I have to go up to Z and then Y. They are similar to each other. This is my similarity statement. And my reason is that shortcut AA. It's not AAA, there's only two A's. AA, angle, angle. In any triangle, if we know two of the angles are the same as two angles in another triangle, well, that third angle has to be the same anyway. Okay? So you've got worksheet 7.3 to start on.